All right, let's talk about connecting two worlds you've probably never put together in the same sentence: your local fast food joint and the global oil and gas industry. It's a pretty wild story of innovation, and it all starts in a very, very greasy place.
So that brings us to this question, which it sounds a little crazy, right? Can the leftover gunk from frying up French fries actually be a key ingredient in drilling for new oil? Well, believe it or not, the short answer is yeah. And the science behind it is actually pretty cool.
Okay, so before we get back to the fries, we have to understand the main character in this story: drilling fluid. You can think of it as the absolute lifeblood of any drilling operation. I mean, as a drill bit chews through miles of rock, this mud is getting pumped down constantly. It cools everything down, carries all the rock debris back up to the surface, and literally keeps the hole from collapsing in on itself. It's essential. But this essential lifeblood, it has a bit of a dark side. The stuff that works the best has always come with some pretty serious trade-offs. See, for decades, the industry's go-to has been what's called an oil-based drilling fluid, or OBDF. It's usually made with petrodiesel. And look, it works great, but it's expensive. And more importantly, it can be toxic. If it spills, that's a big problem for the environment, which has led to much stricter rules and a huge push to find a better way. And that push, that search for a better way, has led scientists to a solution that is as clever as it is, well, unexpected. Instead of petrodiesel, get this: researchers have cooked up a new fluid that uses biodiesel as its base. And not just any biodiesel. This stuff is made from used cooking oil, the gunk that restaurants have to pay to get rid of every single day. They are literally turning trash into a high-tech industrial tool. And what's so brilliant about this process is how they use everything. The waste cooking oil isn't just a one-trick pony. Through a couple of different chemical reactions, they use it to create both the biodiesel that forms the base of the fluid and the special emulsifiers, which are kind of like the glue that holds the whole mixture together. It's a complete start-to-finish recycling system. So here is the million-dollar question. How does this recycled fryer grease fluid actually stack up against the traditional stuff? Let's look at the data. Now, just look at this for a second. The first thing that jumps out is safety. The flash point, that's the temperature where it can ignite, is more than double for biodiesel. On a drill rig, that is a huge safety improvement. On top of that, it's got zero sulfur and it's from a renewable source. I mean, those are massive environmental wins right out of the gate. And the environmental story just gets better. When they actually tested this stuff, the final biodiesel-based drilling fluid, or BBDF, is officially rated as non-toxic. The traditional petrodiesel fluid? Moderately toxic. I mean, that's a night and day difference, especially when you think about offshore drilling, where a spill is a catastrophic event. Okay, so it's safer and it's cleaner. That's great. But can it do the actual job? Can it handle the insane pressures and friction of drilling deep into the earth? So first up is lubricity. Basically, how slippery is it? And for this test, a lower number is better. And the results are, well, pretty clear. The biodiesel fluid is just a better lubricant. It reduces friction more effectively, which means less wear and tear on super expensive equipment and, ultimately, more efficient drilling. It actually outperforms the original. And here is the knockout punch. If some of this fluid does end up in the environment, what happens? Well, the biodiesel fluid is over 70% gone in just 28 days. It breaks down. The old petrodiesel stuff? Barely a quarter of it disappears in that same month. It's just a staggering difference. You know, you don't even have to take my word for it. The researchers themselves summed it up perfectly. They said that because it works so well and it's so much better for the environment, it's actually perfect for some of the most difficult, most complex kinds of drilling we do today. But there's always a but with new tech, right? It's not a magic bullet. It's not perfect right out of the box. There are still some real challenges to figure out. When you dig into all the research, a few hurdles pop up. The fluid starts to struggle when it gets really hot. We're talking above 120 degrees Celsius. It can also get a bit too thick and sludgy in the cold, and there are some issues with how it reacts to certain additives and how stable it is around water over long periods. So yeah, engineers have their work cut out for them. So when you take all that into account, the pros and the cons, what does it all mean for the future? What's the real big picture takeaway here? First, let's just remember the scale we are talking about. The market for drilling fluids was over $11 billion in 2024. This is not a small-time industry. So any change that makes this massive operation even a little bit safer or a little bit greener can have an absolutely enormous global impact.
But really, this whole thing represents an idea that's even bigger than just drilling mud. It's a perfect example of what people call the circular economy. This idea of taking a waste stream that we'd normally just throw away and cleverly transforming it into something valuable. And it's happening in one of the last industries you'd probably expect to see it.
So here we have a technology that in some ways works better, is safer for people, and is worlds better for the planet. But it still has some technical issues to solve. And it leaves us with that one big question. Is this the actual future of drilling, or is this brilliant idea going to end up as just a drop in the barrel?